Everybody loves music, but have you ever thought about why? Well, I'm gonna show you what happens in your brain when you listen to music during physical activities. Why some songs increase your motivation and why listening to music may actually increase your energy level. I'm Ana Jovic and this is your Brain on Music. Today I will focus on the effect of music on perceptual and affective output. My question for today is, how does the brain respond to music when we exercise? Does music increase the use of dissociative thoughts and reduce our perceived exertion, as well as does music enhance perceived enjoyment? Professor Costa Georges is one of the most influential researchers and the most frequently quoted author in the field of research on the influence of music on physical activities. Georges argues that music may be used as a type of legal drug that enhances work output. Therefore, researchers have primarily explored three types of musical effects in the field of exercise and sport. Psychological effects concern how music influences mood, emotion, affect, feeling of pleasure or displeasure, cognition, and behavioral. An effective response to exercise can be defined as the general psychological state of an individual, included but not limited to emotion and mood with a given situation. In its more basic context, affective response is used to describe an individual's subjective experience of all valence responses. The psychophysical effect of music are studied by psychophysicists who are interested in how the brain interacts with the physical world. Psychophysical effects of music are measured during exercise, and the most common effect is perception of physical exertion. One of the key mechanisms that account for reduction in the perception of exertion with musical accompaniment is attentional dissociation. Music can encourage people to focus their attention externally toward the sound and thus away from internal fatigue-related sensation. In essence, dissociation concerns focusing outside the body on task-irrelevant information, for example, landscape, where association concerns focusing inside the body or task-relevant information, for example, breathing. The afferent nervous system has a limited channel capacity, and so sensory stimuli such as music can inhibit the internal fatigue-related cues associated with physical exertion. A key point is that the capacity of music to inhibit such cues is greatly reduced at higher physical activity when the signal strength of physiological feedback overwhelms attentional process. Music has also an ergogenic effect when it improves athletic or exercise performance by either delaying fatigue or increased work capacity. Music is used in three main ways within sport and exercise. The synchronous application of music is typified by the use of the rhythmic aspect of music as type of metronome that regulates movement patterns. The asynchronous use of music entails the absence of consciousness synchronization. Music can also be used as pretext to arouse, relax, or regulate the mood of individual or a team or exercise group prior to competition or activity. Generally, fast, loud music has a stimulative effect, so it can be used as part of psych-up routine, and soft music has a sedative effect, which means that it can be used as sedative or relaxant effect. So, an increase in exercise intensity draws the exercise attentional focus toward bodily sensation, thereby eliciting greater awareness of fatigue-related symptoms, for example, limb discomfort. Conversely, exposure to environmental sensory, for example music, can guide attentional focus toward task-irrelevant cues during exercise. Therefore, exercise-related signals are hypothesized to be in constant competition for attention with external influence. It should be noted that attentional focus is usually allocated to both internal and external sensory cues in tandem. It is not secret that music has the ability to elicit emotional responses. A song can make us feel happy, sad, angry, improved, or motivated. Because of that, many of us reach for the headphones when we go for a run. But how exactly does the brain respond to music when we exercise? It was this that Pigliassi and colleagues set out to answer. The brain mechanisms that underlie the psychological effect of auditory stimuli during physical activity are so far under research. Therefore, they investigated the effect of asynchronous music on real-life physical activity. Pleasant stimuli have the potential not only to stimulate the sensory of the cortex, but also to deactivate area affected by negative sensation. Music-related interventions have the potential to reallocate attentional focus toward external influence, facilitate the control of movements, enhance enjoyment, and induce positive affective memories. Low-frequency components typically upregulate as a means by which to induce a resting state. Accordingly, music guides attention toward task-unrelated thoughts and reduces processing of internal sensory signals. This psychophysiological mechanism is objectively indicated by a reduction in the spectral power of theta waves. Researchers hypothesized that music will rearrange the brain electrical frequency, increase the use on task-relevant thoughts, induce more positive affective response, and enhance enjoyment to a greater degree when compared to other auditory conditions that are devoid of musical components. Therefore, 24 participants were required to walk 400 meters on audio track at the pace of their choice under one of three conditions. Some subjects walked while listening to 6 minutes of song Happy by Pharrell Williams, some participants listened to a podcast of a TED Talk, and some subjects did not listen to any sound. During the walking task, the participants' brain waves were measured using electroencephalography to assess how music or a podcast affect the brain during walking, compared with no auditory stimuli. A 32-channel EEG cup was placed on each participant's scalp. Lower alpha, upper alpha, sensory motor rhythm, and beta waves analyzed to further understanding of the effect of auditory stimuli on electrical activity in the brain. Participants also report perceptual, state attention and perceived exertion, and affective, valence, arousal, and perceived enjoyment outcomes immediately after each exercise. Science assesses how each of these three auditory conditions affect the participants' attention during the walking task, as well as how they affect their feelings of fatigue. The results indicate that music upregulates arousal and hence perceived enjoyment to a greater degree when compared to control and podcast. Asynchronous music enhances affective response, increase the use of dissociative thoughts, and upregulate the beta wave in the frontal and frontal central region of the brain to a greater degree than no-music control and podcast condition. Upregulation of high-frequency waves in the frontal and frontal central area could be associated with psychological benefits that are commonly induced by music during activity of daily life such as walking. Rearrangement of beta frequency in brain appears to elicit a more positive emotional state, where participants are more likely to dissociate from internal sensory signals and focus on task-relevant factors. The researchers found that listening to music led to 28% increase in enjoyment during the walking task compared with no auditory stimuli. Enjoyment was also 30% higher for those who listened to music compared with those who listened to a podcast. This is a more complex experiment that identified the effect of music on motor recruitment and brain connectivity during cycle exercise. Motor unit recruitment is a process by which different motor units are activated to produce a given level and type of muscle contraction. The execution of whole body moves of the exercise in the presence of music is hypothesized to increase affective state. Music is also hypothesized to ameliorate the effect of fatigue-related symptoms during exercise performed at light to moderate intensity. Low and high frequency components of the power spectrum are expected to change in the frontal and central region of the cortex when the participants execute the exercise task in the presence of pleasant environmental stimuli. Music is expected to reduce the frequency of neural outputs that is required to control the working muscle and moderate the communication across somatosensory region. This mechanism may serve to down-modulate exercise-related consciousness, reallocate focal awareness toward pleasant environmental cues, and optimize the neural activation of working muscle. 80 participants exercise on mechanically cycle at light to moderate intensity, at 10% below ventilatory threshold, that is intensity of exercise above which your breathing becomes labored and you feel you just can't draw in as much air as your body wants. They exercise 12 minutes while exposed to stimulative asynchronous music. They also use another auditory stimuli, an audiobook, as a means by which to isolate the effect of musical components, for example melody and harmony, on perceptual and psychophysiological responses. During the exercise, 4 psychological measures were taken at 5 time points. Attentional scale provided an indication as to where participants were allocating their attentional focus, for example music or muscle discomfort. Affective balance, psychological instrument, they examines the hedonic tone of emotional responses, perceived activation, arousal scale, feeling of energy, and perceived exertion. The researchers decided to investigate the effect of music on electrical activity in the brain. Time frequency analysis were used to identify the synchronization, desynchronization, resynchronization cycle at the midline center electrodes to provide the neural activity of lower limbs. The results indicate that music has potential to inhibit alpha resynchronization and decrease the number of motor units required to execute the task. The author hypothesized that psychophysiological mechanism could be represented or more autonomous control of working muscle. Put another way, asynchronous music appears to distract participants. The music in the present study increased the use of dissociative thoughts. Music relieved fatigue-related sensation during the execution of the cycle task, with a large effect of condition evident while the audiobook had no significant effect. This dissociation mechanism served to reduce perceived exertion and induce a more positive affective state. An increase in low-frequency components of the power spectrum, such as theta and alpha waves, might not be directly associated with the state of relaxation, as commonly indicated by behavioral experiments in which participants are tested at rest. It is suggested that upregulation in low-frequency waves could be directly associated with fatigue. Therefore, the brain is hypothesized to increase the power of low-frequency waves as a means by which to slow the body down and induce a resting state. Interestingly, neuroresynchronization was mostly inhibited when participants exercise with music accompaniment. Music appears to reduce the frequency at which the body activates the working muscle. Therefore, the authors hypothesized that reduced brain connectivity in the frontal and central region of the brain could be associated with reduced exercise consciousness that is commonly induced by the presence of dissociative strategies such as pleasant music. This neurophysiological mechanism is proposed to down-modulate neural resynchronization and reduce connectivity across frontal and central region of the cortex with effect on participants' perceived effort and affective state. This experiment is one of the first experiments to investigate the cerebral mechanism underlying the effect of music on high-intensity exercise. During high-intensity activity, the brain selects the most silent signal in the automated manner and duly allocates the most intentional capacity toward them. Environmental stimuli, for example auditory or visual cues, however, have the potential to distract exercise from the physical effect of exertion, improving performance and endurance. An increase in exercise intensity creates an attentional shift from an external focus on the surrounding environment to an internal focus on bodily sensation, such as muscular contraction and respiration. This phenomena occurs gradually with the increasing intensity of exercise. When a given exercise load is sustained for a long duration, the levels of perceived exertion associated with the exercise load increase over time. This shift of attentional focus is referred to as attentional switching and represents the moment in the exercise when attention shifts from internal to external sensation or the other way around. 19 participants performed 2 fatigue tests at 40% of each participant's maximally voluntary contraction until the point when the participants could not longer tolerate the proposed exercise intensity for more than 3 seconds while listening to music or in silence. The authors employed an isometric closed kinetic chain exercise mode and delivered the well-known track Eye of the Tiger in task as a means by which to motivate participants. The track was expected to awake long-term memories of the Rocky movie and evoke positive emotion during exercise-related situations. Electrical activity in the muscle was measured by use of electromyography, which identified the electrical potential generated by muscle cells. 5 EMG surface electrodes were placed on the participant's right leg. Electrical activity in the brain was captured by means of 64-channel quick gap. Selective attention was assessed every 30 seconds by use of the scale that measured the allocation of attentional focus to internal and external sensory information during the execution of physical tasks. Limb discomfort, how much discomfort are you feeling in your leg? Situational motivation, how motivated are you feeling? Affective balance, how are you feeling right now? And felt arousal, how aroused are you feeling right now, were assessed prior to and immediately after the exercise. The results indicate asynchronous music increased the use of dissociative thoughts and enhanced task performance to a greater degree than a no music control condition. The authors showed that music downregulates theta waves in the frontal, center, parietal, and occipital region of the brain. The psychophysiological response appears to be associated with a mechanism pertaining to the suppress of fatigue-related symptoms. Music revealed intervention have potential to reallocate attentional focus toward task-related factors. The afferent feedback is reduced when individuals exercise with asynchronous music. A psychophysiological response that facilitated the execution of movements and optimized the neural activation of working muscle. The results of psychological responses and task performance show that there were not statistically significant difference between music during movement and control condition for felt arousal, situational motivation, and limb discomfort measures. Participants who performed the task under the influence of music demonstrate a greater level of dissociation thoughts. Task performance was significantly different between music during movement and control condition. The electrical activity in the muscle were similar on the time and frequency domains, but participants who executed the motor task under the influence of music had significant improvements in time to execution, meaning that the auditory stimulus partially controlled fatigue and the recruitment of the motor units. Results of electrical activity in the brain indicate significantly difference between control and music condition. When participants executed the motor task in the absence of music, an increase in low-frequency waves was evident in the frontal, center, and parietal region of the cortex. Conversely, listening to music elicited a decrease in theta waves through the entire surface of the brain compared to control condition. The same pattern was identified when participants exercised in the presence of music. The results of the present study indicate that theta waves in music during movement were partially suppressed by music and partly stimulated by exertion-related cues. This means parallel processing of internal and external sensory information. Auditory stimuli have been used in sport and exercise settings to assuage the effect of fatigue-related sensation and render a given activity more pleasant under the normal circumstances. The effect of auditory stimuli on information processing during exercise appears to be trigger responsible for initiating a domino reaction that leads to psychophysiological benefits. Fatigue-related symptoms downregulate high-frequency output to generate greater muscular contraction. Therefore, fatigue-related symptoms cause a substantial increase in low-frequency brain waves such as theta and alpha. Music guide attention externally, induce more positive affective response, upregulate perceived activation and enhance perceived enjoyment to a greater degree. Music reallocates attentional focus toward pleasant sensory stimuli, increase the use of dissociative thoughts, and partly reduce participants' rating of perceived exertion. In other words, interoception sensory cues are partially suppressed as their fatigue-related sensation. Reduce focal awareness, render a more autonomous control of movements, and led participants to report more positive perceptual and affective responses. Interpretation of interoception sensory cues appeared to intensify fatigue-related sensation, for example limb discomfort, increase the connectivity in the frontal and center region of the brain, and dampen neural resynchronization to sustain the improved exercise intensity. Conversely, exercising in the presence of music can lower one's perceived exertion, elicit more positive affective response, reduce the communication across somatosensory regime, inhibit neural resynchronization in the center motor command, and optimize motor control. So, don't forget to bring some good music next time when you go to the gym.